What's up, guys? Welcome back to the channel. So as you can see, this is a different function, guys. If you've been watching these videos on deriving the logarithmic function, this is a different one. If you're new, guys, then here's what I would like to tell you guys. First of all, welcome to the channel. Happy that you finally decided to click on this one. If you didn't know, guys, I made videos on other chapters as well, like your trigonometry, your limits, your binomial theorem, and also the first principle. When we derive from the first principle, I also done those videos on that chapter, and you can go and watch them on the playlist section of this channel. But if you want to watch other derivatives, I also done standard derivative, exponential derivative, and this one right here is the logarithm derivative. So that playlist is gonna appear at the end of this video. So just know that this is part 23 of all the derivatives that I've done, starting from the standard derivatives. All right, so if you are returning, remember that you need to pause this problem this video, pause this video, and then solve it, and let's see if you're gonna get the same answer. All right, now let's start, guys. Let's start. Now this one, guys, it's very tempting for you to do the wrong thing. Some of you may think this 3 is n, but to be honest, this is not n. This is basically you need to simplify this, guys. You need to simplify everything that we do here, because usually we don't have the coefficient of x, but now we have the coefficient of x. How can we solve this? Now yes, we have to go back to our exponents, to our, in fact, laws. So remember this law where we have log, let's just say 3 base 2 plus log x squared base 2. All right, this is a log law. Let me just remind you, reminder. Okay, remember this law where we say log base a n plus log base a m. The answer is gonna be log base a and multiplied by m. All right, you still remember this law? Very important. So what we did, we apply the law here, guys. So this one here, guys, is the law. It is the law, right? You can go back to your logs and you'll see this law. All right, now that's what we did here, in fact. So from here we can start deriving, but before we do that, look at this expression here. Now look at the function here. We have this one, the first term here. Let me just underline it very quickly. We have this first term here. This first term kind of shows us that we are having a constant here. There is no x here, so when we derive this, it's going to give us something else. And then we have the second term here where we have our x. Now let's continue. Now before we find our derivative, we need to go and check our formulas that you're going to use on this function on our left. So we don't have a constant, the coefficient of log, so we can write as log, and then we have ax. But what we have there, we do have a term with the exponent. So when we find dy over dx on this one, we know that this is gonna be n divided by x natural log a, right? So this is our derivative. So if you continue, remember you can continue here, guys, but this is optional. I cannot stress enough about this. You can say x, and then the standard log base is e here, and then we have a. Okay, if you don't understand where this formula is coming from, I made a video here explaining these formulas, guys, where to use them and how certain things came about. Go and watch that video on top there, and then you will be able to understand why we use this formula. All right, so let's continue. Now let's start and write the unknown. We have n, a, which are unknown here. So our n, remember, is our exponent. So when you look at this is tricky because you need to know that n here for the second term is gonna be 2, and then our a is also 2, so they are both 2. The first term, I know some of you, we don't have n anyway, so we do not have n, we have 3n, but you need to pay attention to the first term because this, when we derive, guys, remember when we derive is dy over dx. The first term, it doesn't have x, so it's a constant. So when we derive the constant, you know that this is gonna be 0. Remember that, guys, it's 0, so we don't have to consider this one. We have to derive the other one. So let's continue. Right now, let's look at our right hand side when we change it. So we're gonna have n. What is our n? This is gonna be 2 over what is our we're gonna have x, so we're gonna have x natural log, then our base is gonna be 2. Now if you continue, remember this 0, even if you don't write it, guys, it's all good. So don't write this 0, so this is gonna be if you continue, by the way, this is the answer, guys. Let me just write here first. This is gonna be your answer if you decide to write it here. This is gonna be your answer. That is your final answer. But remember, some of you might decide to continue. Now if you decide to continue, you can change this into logs, to standard log. So this is gonna be x log base base e, then we have 2 here. So this is your other answer if you decide to continue, but I always recommend that you stop here, guys. Usually we want the answer here, but if they say continue, please do so by doing this. All right, guys, I hope you understood this one. There was a lot of information that I needed to remind you, just like this law here, and also that this term here is actually a constant. I hope you managed to see that. And then we're only deriving this second term here. So guys, if it so happen that you didn't understand, you can rewatch the video over and over again, or you can ask the question on the comment section. If it happens that you did understand and you managed to get it right, you can also comment on the comment section and add some information if there is another information you want to add on the comment section. Share this video to your friends because I think this one is one of the most important videos that you should share. And if you haven't subscribed, I don't know what you're waiting for. I think you should subscribe because I'm gonna do lots and lots of videos on mathematics. All right, guys, thank you for watching. Until next time, have a wonderful day. Cheers.